everybody, Kalimera, and welcome to O Economica, all about economics and finance. So, very happy to be with you all today as usual. And I have to say that in my previous video, I made a mistake about the Tobleron, about the Tobleron. And if there is a source of energy into the Tobleron, the Tobleron box goes in this direction, and we have delta of S. That is a mistake because I don't have the degree in physics. I'm not an astrophysics. I don't. This is out of my knowledge, as many things are out of my knowledge. So my quest today is to correct my mistake, and we will see together how easily we can uncover one of the greatest things that have ever been gifted to mankind in form of knowledge. So before doing this, we can actually also discover where are we located. So we are located, these are images of the Milky Way, like a sort of map of the Milky Way. So far as we live in the Milky Way, we float around the Milky Way, and we are here. For those of you who don't know, where are we? We are here. So the sun is here. We are in the Orion Nebula, the Orion Belt, sort of. And basically, we float around the sun. The sun floats all around the Milky Way, does the orbiting of the Milky Way, and it takes billions of years to do that. And so we are here in the periphery of the Milky Way. We are a suburb of the Milky Way. And in the middle, we have this huge beam of mass, energy, and light, which it's supposed to be like a black hole or something, which has so much force, gravitational pull, that keeps all these spiral arms floating around and spinning, because the Milky Way, it's rotating, it's spinning. And it's very nice to see how the shape of this spiral, it has very similar features of geometrically of a Fibonacci sequence. So nothing comes randomly in nature. Even in chaos or in entropy, there is some sort of there is geometry, there are very specific measures. So we live here in this Orion Nebula, and we are far from luckily we are far from the black hole, and we are in the periphery. And here you see there are all these the name that we give to all the astronomers gave name all these parts that they observe with the Home telescope or the Hubble telescope or the Virgo LIGO telescopes, all these big things. And people who have who do research about the universe and astronomy and astrophysics, so they do this daily, and it's their bread and butter knowledge. But because it's not my knowledge, I had to go and take back that's another picture. We are basically here. Orion's sun is there. So but nonetheless, there are things which are not so difficult to understand. And so the other day I made a mistake, and now I will correct myself by reading what I have on my notebook. So the other day I was mumbling about chocolate. Okay, so if we have a Toblerone now, let's okay, let me do this. Let's see if okay. Let's say we have, as I was saying the other day, we have there was the Toblerone. Now we have a box. Okay, and actually we have a source of energy here. Okay, this is the radiant energy. So the energy ejects a pulse of energy from here going into this direction. This box has a length L. So what happens is that the energy basically has some sort of velocity which equals A times C delta of T. Okay, because it takes some time for this pulse of energy to go from the bottom of the box to the top of the box, top of the pop. But what happens is that energy has some pressure here, okay, which is paradoxically what happens the opposite was what I said the other day, which was wrong. So that the box, by recoil of the pressure that it's here, because it's energy pressure, the light goes on this way, but we have pressure here because it's a source of energy. So the box goes into this direction. It has a recoil. So the box ends up here. The box has the same length, okay? I'll try to make it the same length. The length is the same. The box is exactly the same. The source of energy is here, but because there is a recoil, the box ends up here by a distance delta x. And the box has the same mass, m. The center mass of the box, it's the same, m. Okay, it's the same box, same length, but because there is a recoil and the source of energy goes from here to here, okay, c AC time delta t, the time it takes. So that's what happens, okay? And this can give us already a glimpse of the relationship between energy, speed, energy in the form of light, and speed of light and mass. Okay, but we are considering the mass of the box, not we are considering the box as a center mass, and also we'll have to consider the mass, which is the mass of the energy involved here. Okay, we will see in a little while. If I make a mistake, I apologize. I will correct myself. But this is actually this can be actually quite simple. It's simple. If I understood it, it means that it's simple because I am no genius. So what do we know? That when there are bodies which have energy, okay, radiant bodies, these have an isotropic pressure. Isotropic pressure. Better if I don't write it. I call it isotropic pressures. No, I cannot write it. So the pressure, this isotropic pressure, it's by this formula, which is P equals 1/3 P times C squared. Okay. So what happens is that it's like a laser. Today we have lasers, and so we eject the thing. You have a laser, this laser eject energy. Now, portable lasers, they don't give you a recoil, but think of a big box with a big laser. If you eject this source of energy, which is light, then you may have a recoil, like a cannon laser. Okay, that's sort of thing. So the pressure in this direction, it's P equals P times C squared. Okay, which in physics there is a rho. P is also indicates the momentum, but in this case is P is for pressure, I believe. Okay, so this source of energy is called E for energy. We have the mass of the box, which is always the same, does not vary. The length of the box does not vary. What happens is that we have this laser, and it's a powerful source of energy, so we have a recoil, so the box moves backward, but the light still stays here. So this process of velocity of light, the distance and the time, it does not vary. Okay, so we have two different frames of reference. One is the energy inside, and one is the box outside, which recoil and moves back because of this pressure that generates a recoil. Okay, so just give me 1 second. So what happens that during the jet emission of energy, okay, so we have that P equals P times C squared. It's not writing, okay, times C squared, which equals also E over V, the velocity, but we know that V equals this. So this ends up being that energy that it's inside the box equals A times C delta of T. Okay, so while we do all this, we will see slowly how this works out, and it's very simple, very simple. I repeat, if I understood it, it means that it's simple. It's not rocket science. Okay, is the length, it's hell. Okay, we know that it is what it is. Now, we know that we have the recoil velocity, this one, okay? So the recoil velocity, so delta V, because the recoil moves backwards the box, then it has a minus sign, okay, of minus A, minus acceleration, delta of T, which is the difference of time in which this all of this happens at once, okay, which also equals, good lord, okay, minus F over M delta of T. Why? Because A, because from the classic mechanics or the classic physics, we know that basically force equals mass times acceleration, okay? So this happens because basically F equals the mass of a body times acceleration, okay? In the case of you have anything in your an apple in your hands, and the apple falls from your hands to the floor or falls from the tree to the floor, A equals G, which is the gravitational force of attraction of a bigger body that attracts a smaller body. So if we change the F around to know what is A, then we substitute it here. It goes back here, and so delta V equals minus F over M delta T. Okay, this is all very linear and straightforward. Zoom out. Okay, so if we move forward in our substitution of moving around things, okay, here we know that this this unit of acceleration times delta t also equals, can I write this? It doesn't want to work today. It's minus p times a. Okay, let me zoom out. Minus p times a divided m, which is big M, which is the center mass of the box, okay, times delta t, okay, which also equals to, if we go and substitute that, we know that P equals E over A times C delta T, because it's the energy inside of the box, the radiant energy inside the box. We get to what? That minus P, what is the pressure, times A over M delta T equals minus, for God's sake, minus energy over AC. So what we have inside the box, AC delta T, okay, multiplied what? A, multiply this, what we have on top, A delta T over M. So you start to see how whole takes shape in the really famous formula of energy. So we are here, okay? So we started from the box with the length and the center mass M. This box is like a laser. It has a laser inside. The pressure causes a recoil of the box moving forward, but inside the source of energy, the pressure and the energy, the laser energy, it has a velocity which equals A times C delta T, which is how the times vary for all this to happen. Pressure equals isotropic pressures equals its P multiplied C squared. But we also know that the isotropic pressure can be defined as the energy over the velocity, but we know that velocity equals A times C times delta of t. We inject all these substitutions taking into account that the box moves backwards, so we have a negative acceleration backward, and we have these two terms which are multiplying together. But here we have AM and delta T. This can be simplified, I believe. So basically we will get to something like equals E over C times big M. Okay, so we end up here. Okay, for this part, we end up here. But we have to consider also other things. Okay, so that the light pulse, when it's emitted into the box from the bottom to the top, basically, it takes time to travel. Okay, the laser light, when you eject the laser, it takes time from your emitting source to the endpoint to travel. Okay, and this distance can be identified as the length of the box over c, which is the speed of light. Okay, and that's how we can quantify the time the laser takes to travel from the beginning of the box to the end of the box. And at the same time, don't forget that we have a recoil. Okay, now because we have a recoil, we have to consider also that the recoil as moves by a distance delta x. This delta x, I didn't take much space, so I didn't take enough space. So let me divide into halves. Okay, so I'll go slowly. So the recoil is delta x, okay, equals what? Delta v times L over C. Okay, so delta V is because the recoil gives us a negative acceleration, because it's the same magnitude of force or velocity but moves in the opposite direction, because the recoil moves you backwards. Okay, and we have L over C, which is the length of the box over small c, little c, which is the speed of light, the speed of the light laser. Okay, but we also know that delta x then can be written also as minus, oh my good lord, minus E times L over M times C squared. We are getting there. Slowly we are getting there. Times C squared. Okay. Why? Because basically we multiply this term here. We multiply this. Sorry about that. But you understood much better than me. You all understood much better than me. We multiply this term with this. Okay? And we have this as a result. Okay? But this is not actually what we need to consider, because this big M is the mass of the box. Okay? What we are interested in, actually, what causes all of this mumbo jumbo, is little m, is the mass of the energy source, which is inside the box, which sparks the beam of light and causes the recoil. So for the m, big M to move back. Okay. So what we are interested in is this mass, the smaller one. Okay. The mass of the source of energy, not the mass of the box, which contains the source of energy. Okay. So how do we connect? How do we bring together the two things? So we know that little mass m multiplied the length of the box plus the mass center of the big box multiplied delta x, which is the recoil, equals 0. And as I said, as you all know, the this small m, which is the mass of the energy inside the box, has caused the big M to move backwards, okay, with the recoil. So, while instead M inside here, it has covered the distance, which is the length of the box, okay, because it goes from the bottom to the top. Okay, I'm sorry, it is what it is, okay. But the light source here, which has mass m small, it has covered the distance of the length of the box from here to here, okay. The laser goes from here to here. Because the laser is powerful because it push the box here in this direction because there is a recoil. So m, the mass, the box moves backward, okay. Now, because the light inside the box has the distance that is covered in a time delta t with velocity c, okay, is the length of the box, we can basically say, take this formula here, and we know that m, okay, equals what we have here. M, the mass of the box, divided the length of the box, multiplied delta x. Delta x basically gives us the magnitude distance of the recoil of what? Of the box of mass m, which has length l. Delta x is the magnitude of the recoil of the move backwards, okay. If we go and substitute into here, we get to our complete shamble. Sorry. We get to the complete picture, okay, and I'm zooming out and out, because this identity also equals, okay, minus m over L. We substitute delta x with this, with minus energy times the length of the box divided m over c squared. Okay, so m and m go, L and L go. So we end up that little m equals minus energy, the energy of the laser, over c squared. Okay, which basically, if we move it around, means that energy equals the mass of the laser multiplied c squared, speed of light squared. Okay, so the energy inside the box, okay, is the relationship between the mass and the velocity. It's the same as by Newton, that the force equals mass time acceleration, okay. What do we have here? That we are measuring the force of the energy, which is the mass, the little m, which is what? It's the little m, needless to say, is what is inside here, is the source of energy is inside the box, is the little m, okay, times the speed of light. Okay, this is not made to explain relativity, but it's made to explain, to demonstrate why energy equals mass, smaller mass of the source of light, source of energy, multiply the speed of light. Okay, this is what basically what happens with the sun, which is mass of energy, mass of burning gases, which is helium, hydrogen, and then they move at the speed of light, and we get this source of energy that comes onto planet Earth. But don't forget, we are here, we are in the suburbs of the Milky Way. Okay, so what I said the other day was wrong. The Tobleron box doesn't move forward, it moves backward, because the source of energy inside causes the box to have recoil backward. Okay, but what we are interested in is not the mass of the box, but we are interested to the chocolate. So the source of energy which is inside the box, which has a mass m little m. Okay, so because the chocolate inside the box must be smaller than the size of the box to fit inside the box. So we are interested into the mass of chocolate inside the box, which amount of energy generates, and in the how much, in the how fast speed moves inside our mouth to generate this energy. The speed of light. Okay, and yeah, so that's what basically I was saying the other day, which is wrong, and now I have clarified what was that I learned by reading a physics books. Okay, and yes, that's how we get to E equals m times c squared. It's a very simple example, but actually very, very powerful indeed, because it considers this box, which inside has energy like a laser box, and the laser goes from the bottom, covers a distance from starting from the bottom to the top of the box, but the box moves back as a sort of recoil, and so it means that the energy inside it has a pressure, and the mass inside the box generates a force powerful enough to cause a recoil of the big box, which contains the mass inside, the end inside, so forth and so on. We substitute all the formulas that we have, and we get to this one here. So I know that this is not the top maximum quality. I recognize that. So you can watch the video in slow motion again and again and again to see all the identities, basically all the formula substitutions that we have from start to finish. Okay, so we have the pressure equals P times C squared, but we know that is energy times divided velocity, which is then we know that the velocity of the source of energy into the box equals A times C delta T. Box has a length L, it has a mass M, it causes a recoil backwards with velocity minus V, let's say delta X, okay? And yes, then we go and substitute everything here. Delta V, we measure the acceleration backward. We know that acceleration can be engineered back by being force over mass times delta T, okay, and goes backward here. And then we know that our delta T, or our P, equals energy over AC times delta T. So we simplify this formula and we get to minus E over C times M. Now we want to, once we have calculated this, we want to calculate delta of X, okay? Delta of X is caused by the smaller mass of energy inside the box, okay? And so we know that the mass of energy inside the box, it covers a distance in a time. The distance is the length of the box divided C, which is the speed. And so we derive, we know the time, the delta of T, okay? And so we know what is delta of X is delta V, delta velocity time L over C, okay? And so we match the thing together, okay? We have delta X, we substitute delta X, we multiply with our first unit of measure here, okay? And we do it by using this formula here, okay? Little m times L plus m delta X, okay? We derive what is the quantity of the mass of energy which is inside the box. We substitute back delta X that we have found before, okay? So we have minus m over L, because that's how we derive little m. We substitute delta X with this unit of measure, which is minus energy times L over big M, which is the mass of the box, times C. We end up that little m equals minus energy over C squared, which we flip it around, and we know that energy equals little mass times C squared. So that's all from me. And now you know where we live, where do we live, in the periphery on the Milky Way, and what is the source of energy that we enjoy every day, which is sunlight. Okay, so I thank you all for watching this video, and stay tuned with O Economica, because we will have a lot more nice and fascinating content in the main list.